Good day to everyone. I got an email from a student saying, hey, I'm going over some reviews, trying to get ready for the test, and they had specific questions they wanted some explanation on. So question 3, part H was the first one, so I'll go over that. So list 3 or more terms that complete, this is chapter 1, what was it? Chapter 1 review. So on page 36 in the book. List 3 more terms that complete a pattern in each of the sequences and tell whether your sequence is arithmetic, geometric, or neither. Now, in this case, sequences oftentimes follow some pretty predictable patterns that we've seen before. Arithmetic, we know it's going to have a common difference. Geometric, we know it's going to have that common ratio, that multiplying piece. Well, let's take a look and see. Some of them you can kind of tell also don't meet either of those, but they still form a really fancy pattern. Like this first one, you can see it goes +1, then +2, +3, +4. So that's a quick pattern to find. That as you kind of see that, you can use that common differences. Now you could do the same thing with common differences on part H. Let me just throw some white space in here and kind of see. So if you were to do this, right, this is 7. The next one goes up 19. What's the next one go up here? 37. Okay. And so if we kind of come down a little bit more, then 719 is 12. And here 20, so 18. So we could say, oh, well, this is going up +6. The next one go up +6. That'd be a 24. So then we add 24 to here, and we add that on to get to the next term. So we could use what's known as not first differences, but second differences might form a sequence. Okay, so third differences would be constant if that was the case. So 6, 6, and then go on from there. Okay, but there's something else that I mentioned to everyone that's kind of a good thing to do as well is you got to be thinking about other things that could help make up the numbers. Now, one that we did in class that came from the canoe was recognizing a pattern like this. Okay. And yes, there is a really nice, kind of I can see I add 3, then add 5, then add 7, then add 9, and that pattern does hold. Okay, that pattern does hold. But I also showed it visually in class where I did some dots. There's one dot, and then the next one I got to 4. So I would add 3. So the reason I add 3 is it gets me to the next little shape that looks like this. And then I add 5. So 1, 2, 3, 4, 5. And I keep making these beautiful squares. And that's kind of where this is one of the figurate numbers. 1, 2, 3, 4, 5, 6, 7. When I add 7, I get the next square. But these are called square numbers. Now, if you didn't see that right off the bat, one thing you can do is think about how could you make the number 1? You can think about it with either addition or multiplication. Well, what would you multiply to get the number 1? Maybe you'd say, okay, well, 1 times 1. And then what would you multiply to get the number 4? Now you could say 1 times 4. That would be true, but you could also say, but what about 2 times 2? Oh, okay, 2 times 2. I like that. And that kind of matches the pattern that we saw up first. 9 could be 1 times 9 or 3 times 3. Oh, 3 times 3. And then now as you start to see that, you might be thinking, oh, 16 might be, oh, it is 4 times 4. And I've got myself a really nice pattern here. And you could even write it a little differently. You could write it as 1 squared, 2 squared, 3 squared, 4 squared, and so on, so that any term could be written as n squared. Okay, so that's an approach. Okay, and you can actually match that up right over here to the idea that these are actually squares. So I can see here, this forms a 2 by 2 square, which gives me 4 dots. The next one creates a 3 by 3 square, and if you count up all the dots, turns out there's 9 dots, and so on. Okay. All right, well, let's take a look. Let me clear that out and redraw. So now let's keep that idea in mind. If I'm not sure what's going on with the numbers, I can always try something, right? No reason to leave it blank. So 1, how can I get to the number 1? Well, I could do 1 times 1. Oops. Oops. Lost my ability to draw there for 1 times 1. Okay. Then when I get to 8, it would be what? 2 times 4, right? 9, maybe like 3 times 9, right? 64, maybe 4 times 16. And it really doesn't still, maybe you don't see the pattern yet, but the reason I started with the one that I did is to say, well, wait a minute. If I have a 1, a 4, and then others, right? I've got a 9 and I can't even tell where my my pen went. Having a little technical glitch there. Sorry about that. 9 and 16. You could say that pattern of 1, 4, 9, 16. I know that one. And I could even factor that down. So 1 becomes 1 times 1. 4 becomes 2 times 2. 9 becomes 3 times 3. So what we're doing is something called factoring. We break a number down into its factors. And so now this first number really becomes 1 times 1 times 1. 2 times 2 times 2 for the second number. 3 times 3 times 3. So I could write these with an exponent because that would tie them all together. And we could continue with that. Okay, so definitely not arithmetic. It's not geometric because I'm not multiplying by the same thing each time, but there's definitely a pattern here. And each term that you could get to might look like this. So don't forget about your fundamentals. If you see something, look for a pattern. If you don't see the pattern, it's okay to try other operations. In this case, factoring. All right, let's see here. The other question, oops. I got to move to the next page, I think. Question number 23 was the next one that the student had. 23, okay. If for every natural number n, the sum of the first n terms of a certain sequence is n squared minus n. Okay. Well, let's see here. The sum of the sequence is n squared minus n. Well, let's think about some of the patterns we've seen, right? So 1 plus 2 plus 3 plus dot 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 all the way out to n. We've done that one. And if we go backwards, right, plus n minus 1 plus all the way down to 1. When we add this, we got two s's. I get an n plus 1. It happens n times, and then I divide by 2. So my final result for this one would be n plus 1 times n, the whole thing divided by 2. Okay. All right, so there's that one. Now, this sequence is not that. And it says the certain sequence is n squared minus n. So if I was to kind of use that wonderful factoring idea here, n squared minus n is equal to n times n minus 1, right? Now it's an arithmetic sequence and every term has to kind of add up to this. So I think what I want to do is take what I had before, right? Take what I had before. Notice here when I add an n and a 1, I get n plus 1, and I have n terms. So I feel like maybe I want to try something like that. So I need the same number of terms. I just need them to add up to a little bit less. So what if I took 2 away from every single term? That could do it, right? That could do it. Because if I took 2 away, that would move from a plus 1 to a minus 1. Okay, so if I wanted to think about that sequence, let me get a little bit of white space over here so I have a little bit of room to write. Okay, so what would that look like? So instead of 1, 2, 3, dot, 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 up to n, I would need to take away 2 for everything. Because again, I want to keep the same number of terms. I just need every term to be 2 less. Okay, so if I do 2 less, then that'd be -1, -2, then 1, then 2, and so on, all the way down to n minus 2. Okay. So if I took 2 away from it, then that would, oh, but take a look now. Now, if I wrote this forwards and backwards, I'd have an n minus 2 here. When I add them together, I get n minus 3. So taking 2 away has actually caused me to go down by 4 from what I was previously. Oh, okay. Well, why don't we try taking and learning from that piece, give ourselves a little white space and say, okay, so let's not go down quite as far. Again, this is me thinking out loud, by the way. I may have known a shorter way to do it, but if you're looking at this as a new, just trying it out, these are the thought process that probably go through your mind or could go through your mind. Okay, what do I want to do? So let me try it again. 1, 2, 3, all the way to n. And now I'll just take 1 away. and see if I can get there. Aha, so now if I wrote this one, if I said, what happens if I add this up, 0 plus 1 plus 2 plus dot, 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 all the way out to n minus 1, and then I write it backwards as n minus 1 plus n minus 2 dot, 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 plus 0. When I add that up, I get 2s. That gives me an n minus 1 for every term. I know there's exactly the same number, one-to-one correspondence with what I had before. And so therefore my sum is n minus 1 times n divided by 2. Okay, and that is very close to what I had here. The sum has to be this thing. So I'm very close. I have the n squared minus n, but mine is divided by 2, and theirs isn't divided by 2. So why don't I just, what if I multiply every one of these numbers over here by 2? Right? So 0, 2, 4, dot, 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 up to 2 times n minus 1. Then when I bring it down here, I have 2 times n minus 1 plus 0, right? 2 times n minus 2 plus 2, all the way down to 2 times n. So in the end of the day, each one of these becomes a 2 times n minus 1. When I divide by 2, guess what? Those cancel off. So there it is. So my sequence would be 0, 2, 4, 6, 8, 10, all the way, right, out to 2 times n minus 1. Yep, because if I write it backwards, I get 2 times n minus 1. I have n terms total. And so 2 times n minus 1, multiply by n, then divide by 2 to get back to just my initial sequence, and I'm at the exact piece they want. So they now say find the fourth term. So first, second, third, fourth, and there's my fourth term. My fourth term would be the number 6. Okay. Let's see here. Next up was 24, part C. Okay, so part C. Now this one is a little, maybe a little funky, if you will. It says it is a Fibonacci style sequence. And so let me zoom in just a little bit and then scroll down. So there it is. Okay, Fibonacci sequence. So if I was looking at this to say Fibonacci, I would need to, I'm probably going to need to give myself a little white space here. There we go. Okay. Fibonacci sequence, just to remind you, is the ones where I had like a number 1, then a number 1, then a number 2, 3, and I would add the 2 numbers to make the next one. Add these 2 to make the next one. Add these 2 to make the next one. So the next number would be 5. Then the next number would be 8. Then the next number would be 13, and so forth. Okay. All right, so that's the idea. So just to kind of give an idea up here, if I started with 13, right? You could say, okay, so I have 13. My next number, I don't know what it is. So if you want to be algebraic, put X in there if you feel comfortable with that. If not, put a little cloud or something. I don't care. It doesn't matter. Put something in there so that you can say, okay, here's, oops, lost my pen connection for a second. Oh, there. I think I'm back. I gotta stop sharing and come back. I gotta make sure. I just had a really weird glitch on my screen. So stop sharing. Okay, well, there's me. Let's see. Let me go back and see if it's working now. Am I sharing? Let's see here. Okay, it says I'm sharing, so I think we're back to good. Sorry about that. Technology, right? Just gotta roll with the punches. So let's go with white space again. Okay, so we kind of have the idea of what we're looking for. And so let's take the first one, right? Just as an example. So I've had 13. My next number, I don't know what it is. I'll call it a cloud. Again, you could call it X. It's probably easier to call it X or B or A or something like that. So the next term would be 13 plus cloud, right? Remember, because we add these two to get the next one. And then the next term is 27, and the 27 comes from adding these two components together. So that means 13 plus a cloud has got to give me 27. And this is, again, this is why the prerequisite is the algebra, because we need that skill. Take away 13 from each side, and you end up with a a cloud plus a cloud. If you wanted to, you could write two clouds, and that gives me 14. So the cloud is 7, because two clouds would give you 14. So if this was a 7, then 13 plus 7 would be 20. 20 plus 7 would get me to 27. Okay, so that works out. Okay, let's jump back in here again, get a little bit of white space. And now this one is a little bit different though, right? Because it says A, and then I have to end with B. All right, well, don't let that change what you do. Okay, they're basically saying, could you solve this problem for any starting and ending value? We just did it for 13 and 27. And we just did it for that one. So what would I do different? Well, I'd just say B is my starting. That's a horrible B. Let's get rid of that one and pretend we didn't see that on the screen. There's a B. Okay, my next term, I'll just call it cloud again, right? My next term would be B plus the cloud. Okay, my last term is A, but how do I get there? I'd add those two, and that would get me to A. So A is equal to B plus cloud plus cloud. So now if I wanted to, I could subtract B on both sides. And so now I have A minus B, which I know is a little abstract for some of you. You're looking for a number. This is a number. It's just kind of holding the place because I don't exactly know what I have there. And then a cloud plus a cloud would give me two clouds. And so if I want to get one cloud by itself, I just divide by 2. So what I have is A minus B divided by 2. And that would be what I would put in the first one. And in the next spot would be B plus that. So let's take a look and see if we can't figure out what that kind of looks like. Maybe give us a little bit more fine tuning. Okay, so I start with B. My next term would be A minus B all over 2, right? And then I have this, but I want you to notice B, the next one has an over 2, and I need to add them together. It might be good to write those with a common denominator. So I'll just write this as 2B over 2. That way, when I add these two together, what I really have is A minus B over 2 plus 2B over 2, right? And if I add those together, that would give me at the end A plus 2 B's but minus a B. So that'd be just plus a B and the whole thing over 2. So that's what goes right here. There's my second term. And now you can check it, right? You could add these together and see if you should come back with A itself. Let's check. So A minus B over 2 plus A plus B over 2, right? Now they have a common denominator already. So it's really A minus B plus A plus B. And this is where we get to use a little algebra. The minus B and the plus B, those kind of eliminate. And that leaves you with 2 A's, but you're dividing by 2. And if you simplify that, you get back to just A. All right, so here you go. There it is. Now, what I wanted to show you why I think this problem is so cool is once you get to the point, what we just did is we just created a formula. We did. We just created a formula. You may not see it that way, but we just created a formula. Now, here's the fun fact. If you had done this problem in reverse, if you started with part C, then going back to parts A and B would be pretty quick. Let me show you. So in part A, right, the first term is 13. The last term is 27. So all I do is plug those into my sequence here. So my next term would be A minus B divided by 2. My next term would be A plus B over 2. And all I do is plug the numbers in. So what do I have? 27 minus 13. What is that? That's 14 divided by 2. That's the number 7. Next number, I just add them together. 27 plus 13 would give me 40, and 40 divided by 2 is 20. So I can find those terms to fill out that sequence really quickly. And I could do it for part B as well. So I can now do, okay, what do? I subtract these two numbers. Well, the subtraction gives me, what is that, 26? Divide by 2, that tells me 13. Now I can go through and do the Fibonacci part, or I could just add these two together, which gives me 290. So 300, but I divide by 2 gives me 150. So I could get those terms pretty quickly. And that's the cool thing about math is you actually have the power to kind of create a formula. If you end up having to do a whole lot of repetitive stuff, with numbers, stop. Go down and try to do it without numbers. You might be able to create a beautiful formula for yourself so that all the ones with numbers become significantly easier. Okay. And the last question was 26. Okay. And this one says, find a number to replace the question mark in the figure below. Now, there might be multiple ways to do this, if you want to be perfectly honest, right? Might be multiple ways. So it's a little hard to say that there is exactly one way to do it, but you want to try to find something that works. And if this was a test question, right, I just expect you to explain, why does your answer work? Let me get a little white space drawn on the screen. There we go. We'll get rid of everything else. All right, let's give it a shot together. So what am I looking for? I'm looking for patterns, right? Now I don't know what this is, but what I see here is I see a 4 on top. Underneath it is a 6 and then a 2. So maybe there's a connection with numbers that are going down, or maybe it's with numbers that are going across. Let's see here, 4, then 2, then 1, then 6. I don't see a connection on the diagonals. Maybe like here, 9 and 10 are kind of on a diagonal and they're right next to 19. So maybe there's a connection like that, right? Do you see what I'm saying? How the 9 and the 10 get me to 19. So maybe it's like a down and over like addition. Let's check it. 4 plus 2 gets me to 6. Okay. Okay, that kind of works. Let's hear. Then let's try it again. 1 plus 6 gets me to 7. Okay. Okay. Okay, so I kind of like that. So if we were doing that to find the missing piece, maybe we would do something like what? This. So 2 plus 1. So maybe this is 3. Let's check and see if it works then, right? Because it has to work. So 6 plus 3 would get me to 9. That makes sense. 3 plus 7 would get me to 10. That makes sense. So yeah, 3 kind of fits in there and seems to work out okay. There might be another thing. I mean, you could do it with subtraction too, maybe, right? If we get rid of these symbols just a little bit here, right? Maybe you're looking and you're like, hey, 6 minus 2 gets me to 4. You're going that way, right? 19 minus 10 gets me to 9. That's fine. I mean, addition and subtraction kind of do partner up pretty well. So 7 minus 6 is 1. Well, 10 minus 7 gets me to 3. So again, my question mark would be 3. So anyway, there you go. Hopefully this was helpful. And I'll try to make a few short videos for the other sections, and we'll chat with you soon. All right, off you go.